Okay. All right. Now you might be thinking, wait a minute, how do we get the vertex though? Well, you actually can get it. There's formulas for it. We'll get to that shortly. But there's something else I want to show also. There's something called the axis of symmetry. It's a vertical line that goes through the vertex. And it turns out the graph is symmetric. It's always symmetric about that vertical line. Now, what do I mean by that? Well, you can imagine, hopefully you could do this, taking the graph and folding it like a piece of paper about that axis of symmetry. If you were to imagine doing that, folding the graph about the axis of symmetry, then both halves of the graph would actually line up. They would overlap each other. That's what would happen. I mean, you can imagine doing that. And this is actually y equals x squared plus 1. Here it turns out the y-axis, which is x equals 0, that vertical line, that's actually the axis of symmetry here. And if you go back to the other graph, here, same thing. It's always a vertical line through the vertex. Okay? It's always that vertical line. Okay, good. Now, in the definition on the very first slide, we did write down, the quadratic function. We have ax squared plus bx plus c. It turns out there's another way to write the quadratic function. You can write it in this form. The a is the same. So we have a times x minus h squared plus k. H and k are real numbers. Now, how do we actually get this form? You have to use a method called completing the square. So I'm not going to cover that for time consideration, okay? But you actually could go from the first form we saw to this form by completing the square. And this is what they call the standard form of the quadratic function. And you might be thinking, before you saw the bottom here, why would we even bother doing that? Why can't we just stick with the other form? Well, it turns out H and K are very useful. They're the coordinates for the vertex. In other words, the vertex of the graph of this, the parabola, is HK. So if you happen to have this form, okay, you have the vertex immediately, so to say, we have HK. And not only that, you have the axis of symmetry. That's the vertical line through the vertex. And if this is the vertex, HK, the vertical line then is XX equals H. That's the axis of symmetry. Okay. Now, one could, just if you're not given this form, you could always just complete the square to obtain this form. But what's nice is we don't have to. Namely, if you happen to have this form instead, I mean, the domain, of course, is the same as before, but you can actually get the vertex easily knowing B and A. Because the vertex has these coordinates, it turns out. In other words, you can actually get the vertex from B, A, and C. Namely, this is the point, the vertex. And the axis of symmetry is X equals negative B over 2A. Okay, that's good. So you would have to know these formulas then. But again, you could actually go from one form to the other. I mean, if you started out in the standard form, to get this form, you would just FOIL. And to go the other way, you would have to complete the square. But in a sense, you really don't if you know these formulas, because by comparison, H turns out to be negative B over 2 times A, and K is actually just F of that, F of H. F is the function. I'm not sure if people generally remember the formulas, or if they use the procedure. I mean, the procedure of completing the square is actually very useful. It's actually where the quadratic formula comes from. It's actually how one can prove the quadratic formula. So it is actually very useful to do, to know. I mean, depending on the quadratic function you're given, completing the square might be a lot easier to work with. That's a different story, though. But again, for time consideration, I'm not going to go through completing the square. I mean, it's not an easy process, which I understand. So, all right. Are there any questions about this stuff? Okay, well, let's keep going then. And this is just, some other stuff. I think that's good. It's easy to get the y-intercept for any function. In fact, it's always f of 0, if f is that function. That's what the y-intercept always is, f of 0. Okay. And the x-intercept, you actually would solve this equation for x. And again, this is for any function, not just for quadratic functions, but for any function. I mean, what's nice with quadratic functions, you can actually get this, well, we have different methods for it. You could factor, which sometimes is more useful than the quadratic formula. Or you could just use the quadratic formula. Basically, you're going to learn what you did in section 1.2. Completing the square can also be useful here. But again, I'm not going to go through that. And there's just some other stuff. As a reminder, the domain is always, for quadratic functions, all real numbers. The range, as we saw, will actually depend on A. It actually does depend on the vertex. It turns out, if your A is positive, the range is actually going to be the interval from the y coordinate of the vertex up to infinity. And if the range is, if A is negative, it's going to go from the y coordinate down to of the vertex down to minus infinity. So it's going to go up or down, basically, the range. But wait. It's going to go up to infinity or down to minus infinity. When we do some examples, it will be a little more clear. Okay. In fact, let's do some now. So let's say we have this example. Let's say this is our function, okay? It's still good to be able to graph it by hand. I know we have Desmos and all these fancy technology apps and hardware and all that stuff, smartphones that can graph it for us, but it's really good to graph it to know how to graph it by hand. You don't want computers to do the work for you. You want to use it as a tool, so to say. All right. Anyway, so here, what's our A? Well, we have A is 2, right? We have B is 8, and we have C is minus 3. That's what we have here. Okay. So what's our vertex? Well, to get the vertex, we have to calculate negative B over 2 times A, right? If you go back, let me go back to the formula, right? This is our vertex. So we have to calculate negative B over 2A. All right, so let's do that. So B is 8, A is 2. We get negative 8 over 2 times 2. But that's just negative 8 over 4, which of course is negative 2. Okay, so that's the x coordinate of the vertex. For the y coordinate, we just do f of this. So f of, right? F of minus b over 2a. So f of, oh, wrong slide, sorry. There we go. F of minus b over 2a. That's f of minus 2, right? Which is 2 times minus, again, we just plug it into the function, right? For x, 2 times minus 2 squared plus 8 times minus 2, minus 3. And you work that out, you end up getting minus 11. So we have the vertex, right? That's this point. We also know the axis of symmetry, right? That's the vertical line through the vertex, which is x equals the x coordinate. And yes, we also do have the y-intercept. That's actually very easy. It's just the constant term. Yeah.
So to get the y part of the vertex, we basically just plugged in -2 into ax squared plus bx plus c.
Exactly, into the function.
Okay, thank you.
Okay, you're welcome. Good question. So that's how we got the vertex, right? And notice that since a is 2, we actually know a lot about the graph already. Let me, if I can get this, here we go. Right away, we know the graph is going to open upward, right? We know that for, wait, let me think, that came out bad. Let me graph that better. There we go. Okay. Bear with me. Not the best artist, I guess that's good enough for now. I mean, you'll see a better picture shortly, but we know right away the graph opens upward. We know that the point at the bottom is the vertex, right? Which is -2, -11. Okay. We know that the axis of symmetry is x equals -2, right? We know that. So we know something about this. We also actually have the range already. If we were to get the range right away, it would be from -11, because since it opens upward, it's -11, comma, infinity. When we graph it, you'll see what I mean, right? Because again, if a is positive, as in that case with the example, the range will go from the y coordinate of the vertex to infinity. The y coordinate here is -11. So since a is 2, which is positive, this is what the range is going to look like. We'll graph it shortly, though. I guess what I'm trying to show you is we actually do know a lot about the graph already. Let me just quickly do this.